Okay, your last video for homework due on Monday the 7th, section 2.3, the product and quotient rules. So take a minute please, pause the video, attempt the warm-up problem, find the derivative of the four following functions. Okay, so the only rules we've learned thus far are, we have our power rule, and we know that we can derive functions. We can apply the power rule. The derivative of a constant is 0 only if we're adding or subtracting two functions. So if you attempted the warm-up, hopefully you first expanded this binomial, square the first term, double the product, square the last term, and then you're able to apply each of your derivative rules. So the derivative would be 8x minus 28. For this one, rewrite your function first by splitting up the numerator into 3 separate terms. Rewriting each term, canceling the common base and rewriting it so we can use the power rule. Then the derivative of each of these, derivative of 4 is 0, negative 10x to the negative 3, minus 21x to the negative 4, and then the final step, rewrite each term with positive exponents. Okay, when you get to 3 and 4, however, there's nothing more algebraically you can do to separate these functions into the sum or difference of terms that you could then apply the power rule or our trig derivatives. So that's where the product and quotient rules come in. So the product rule, to find the derivative of the product of two functions that are in terms of x. This is very different from the rule that we learned in 2.2, the derivative of a constant times a function. You just keep that coefficient out front and multiply by the derivative of x. And they're so different because the constant obviously is just a real number. It has no variable. When we're multiplying two functions together, the derivative rule, first function times the derivative of the second function plus the second function times the derivative of the first function. And you'll hear me say that over and over and over. First times the derivative of the second plus second times the derivative of the first. So let's go back to our warm-up problem. F of x equals 4x times the cosine of x. So the first thing to get used to, identifying what the first and second functions are. They're the two functions in terms of x that are being multiplied. So using the product rule, first, literally we rewrite what the first function is. Times the derivative of the second, derivative of cosine is negative sine, plus the second function times the derivative of the first function. And then just sort of cleaning that up, plus 4 cosine x, this is your derivative. And that's it. Now you'll have to get used to saying it in your head. First times the derivative of the second, plus second times the derivative of the first. Okay, the product rule becomes a bit of a preference for two reasons. Now first, we could rewrite this function by expanding the binomial. That's what we learned, the technique you learned on, or used on the warm-up. Square the first, double the product, square the last term. Then when we apply our derivative rules, power rule gives us 4t cubed minus 8t, and then the derivative of 4 is just 0. If we wanted to use the product rule, we would rewrite this function as t squared minus 2 times t squared minus 2, where the first and second functions just happen to be the exact same. So using the product rule, the derivative, first function times the derivative of the second function plus second function times the derivative of the first function. Now, we know how simple this answer is from expanding and then applying the power rule. So we have to be sure that we can in fact get it to be the same answer. So if I factor out a t squared minus 2 from both terms, I'm left with 2t from the first term plus 2t from the second term, and I get 4t times t squared minus 2, which if we look here, greatest common factor is 4t, and we'd be left with t squared minus 2. So both methods give us the exact same derivative, as it should. We started with the same function. So the product rule, if you have just an algebraic expression, it's up to you if you want to apply algebra techniques and then find the derivative, or use the product rule. The goal, though, you have to be sure you get it to the most simplified answer for the derivative. In the case of the warm-up, you didn't have an option but to use the product rule. Okay, what if I asked you to derive pi squared times x minus 1? The derivative here, pi squared is just a constant, times the derivative of x minus 1 is 1, so this derivative would just be pi squared. So you don't always need the product rule. What you guys are going to develop the more you practice problems is recognizing when to use the product rule. You don't need it here because pi squared is not a function in terms of x. If I gave you x squared times 3 plus x to the negative 1, again, we could certainly use product rule, but I think it would be easier to distribute the x squared, multiplying like bases, add the exponents together, and then this becomes a very simple application of the power rule. So it's up to you, and the more you practice, you'll develop a quicker method of recognizing what rule to use. Okay, now the quotient rule. Not as simple. So the derivative of f of x divided by g of x, of course provided that the denominator is not equal to 0. Now the order of the quotient rule matters. Product rule doesn't, because you're just multiplying and adding, so the order in which you multiply and add doesn't matter. Quotient rule, bottom function times the derivative of the top function minus top function times the derivative of the bottom function all over bottom function squared. So the order matters because that's subtraction, alright? So we know that 1 minus 2 and 2 minus 1 give us completely different answers. So you do have to be very careful with the quotient rule. Alright, let's go back to the warm-up problem. Our function was sine x divided by 4x. Okay, so for the top and bottom, when I say bottom times the derivative of the top, it's literally just you rewrite the bottom function, multiply it by the derivative of the sine function, which is cosine of x, minus top function, so rewrite sine of x, times the derivative of the bottom function, derivative of 4x is 4, all over the bottom function squared. Now the quotient rule, you'll find, will take you a little bit of simplifying. Alright, so I have 16x squared, distributing that squared. Now I know that I have a 4 common in each term, so my most simplified answer for my derivative, x cosine x minus sine x all over 4x squared. Now I can't cancel an x because this second term doesn't have an x with it, so this would be the most simplified answer. Now if you have a rational expression that looks like this, x squared plus 2x divided by x, again you have an algebraic simplification That'll make this derivative a lot easier for you. Separate the numerator by putting it over the common denominator, and then your function just simplifies to x plus 2. Then the derivative of that function is just 1. So if you can do any type of simplifying before you take a derivative, it'll make the work that much easier for you. Alright, let's look at something like f of x equals x over x minus 2, however. You can never break up a denominator. So I couldn't write this as x over x minus x over 2 and then use the power rule. Okay, not mathematically correct. So this problem needs the quotient rule. So the derivative, bottom function times the derivative of the top, minus top times the derivative of the bottom, all over bottom function squared. So simplifying a little, x minus 2 minus x, and then the x's cancel, and my derivative would be x minus 2 squared. Alright, everybody's favorite, trig function derivatives. So we already know that the derivative of the sine function is positive cosine of x, and we know the derivative of the cosine function is negative sine x. Okay, so now let's look at the derivative of the tangent function. So the tangent function can be rewritten as the quotient, sine x divided by cosine of x. Well, using the quotient rule then, bottom function times the derivative of the top function minus top function times the derivative of the bottom function all over bottom function squared. So we get cosine squared x plus sine squared x all over cosine squared x. We know this is the Pythagorean identity, so 1 over cosine squared x. So the derivative of the tangent function, the reciprocal of cosine squared is secant squared of x. Okay? So we will do this in class, but I want you to have this in your notes. The derivative of the secant function, we will prove them in class, I should say, is secant x tan of x. The derivative of the cosecant function is negative cosecant of x cotangent of x, and the derivative of the cotangent function is negative cosecant squared x. Alright, we'll leave it there. You guys have homework that was assigned at the end of all the 2s. 2, number 2, part 2. You have that video, you have the homework problems, and then we'll have this to discuss on Monday as well. Have a great weekend.